Welcome to Everyday Entrepreneurs Everywhere with your host, Chris Parker.
And welcome back to Everyday Entrepreneurs Everywhere. This is Chris Parker, and I am with Tomasz Wierzchowski, who is originally from Poland, as he explained to me, born, raised, and educated. However, currently he's in the United Kingdom, and he's into robotics. And I'm really fascinated to talk to Tomasz about some of his projects, the ones he's working on now, and as well as the past, because I know very, very little about robotics. So I'm very curious to see what kind of entrepreneurial activities he's gotten up to. So Tomasz, thank you so much for joining. Can you please share with everyone what you do and why do you do what you do?
Absolutely. Thank you. Thank you very much for invitation, first of all, to this podcast, for introduction. As you explained, I'm roboticist and systems engineer. So I see myself as, let's say, dual specialty, because I think both of these things come together, which I'll maybe talk a bit more in details later. And I had the unique opportunity, one of the unique opportunities to work across my career in robotics for industrial projects across Europe. Happy to discuss more details about this. I think also throughout my career, my role and focus evolved quite nice, till now I'm holding Chief Technology Officer position at agriculture robotics startup called HayBeeSee, where very briefly we're developing a very novel jumping robots for intensive scouting of crops in very, very short details. And happy to discuss some of the interesting topics in robotics today.
We will dive into some of that. But before we get there, I'm still curious about the why question. So what is it about you that, has brought you down this path over time? Why are you in robotics?
Yeah, it's a good question. Yeah, very good question. So I think when I look back now into my career choices, of course, education is one of the big ones. So I was always in STEM. I was very much into physics during pretty high school. And then I had this kind of very major decision we have to make, either go into more academic physics degree or go to something more applied. I always liked also playing with practical stuff, model making, also maybe a bit of electronics, but nothing like too crazy. Not too much of programming, just a bit. I was fascinated about how things are built, and I really liked very practical, experimental work, the things that I can see the effect of my work pretty much. So I get a consultation, long story short, with someone my family knew who was a physicist, and he said to me, absolutely don't do a physics degree, especially in Poland, because this is not the way, especially nowadays.
Wow, why not? What is so horrible about physics in Poland? Is it different there? Different laws of physics?
It was career advice. It was not like your passion. So if you're passionate, but it was more about if you want to earn decent money and have many opportunities, you are still young, it was high school, do, for example, computer science or maybe do robotics. So this was very pragmatic, someone who cared about me and my family. So this was this, and this was maybe also about how in Central Eastern Europe the academic system works and how it's evolving. I think now it's better than 15 years ago, but still, for example, opportunities are different than in academics, institutes. I'm not saying about the quality of research, it's just about the realities of, let's say, the pay and the conditions. But then maybe it was a bit biased, but I really liked I got at least very clear direction, not to pursue directly maybe what I was thinking I was going to do. So I chosen to do the degree in robotics. And I think it took me 3 years before I figured out that mobile robotics is something I want to be involved in, because I had to go over, of course, undergraduate, which is probably a bit different than in like Western Europe. So this education system is, I think, it's not as specialized. It is specialized in few areas, so it's very deep in each of the subjects. So like physics or like algebra or some fundamental problems of like control robotics. They are very well, I think, taught in early years, more than in Western Europe, which means you probably have more chance to find out what you like and what you don't. And if you do it right, you have better background, like this, let's say, more like T-shaped backgrounds, if you know the notation that you, but T with a bit kind of bigger T part. And then after 3 years, long story short, I got involved in a few like research projects, and then I got like on a double degree with Cranfield University in UK on autonomous vehicle dynamics and control. Meanwhile, I started building my own stuff, not yet robots, but embedded systems. So my own electronics, PCBs, embedded software. And yes, from then I knew, wow, this is what you can do nowadays with, well, not just with electronics, but actually if you build stuff which can actually especially like drones, because that's what I was very passionate about. This is very novel technology and like very disruptive. You can do it's very fun, first of all. So it's extremely, I would say, motivational to work on this. But on the other side, opportunities, like business opportunities, impact opportunities are endless. There will be, and there's not many people doing this. So that's kind of that was my motivation, and that kept me, till today. Even though it was difficult, I would say sometimes to find other opportunities if you want to switch.
And you're we're going to get into some of your career background in a bit, I hope. And your current project is sort of in AgTech. Are you in love with agriculture, or is the industry not really relevant, or how do you see the context? Because it looks like you've been evolving through. For example, you've worked with Dyson in the past, which is, an incredible household brand that I know and love. Now you're in agriculture. How does the industry or the context influence your passion?
Yeah, that's a very good question, actually. So I think every time I explore new projects to join, for whatever reasons, I really would like to understand the industry. And I think I had the pleasure to work almost on all projects, which in the end actually really were impactful. So there was a lot of impact. And I learned a lot about these industries, even though I had no clue about industry when I was joining, or had little clue. And what I find very beautiful about robotics and very motivational is that actually technologies that you develop, of course, some will be very tailored to each industry. However, if you develop, for example, some novel way of locomotion, so let's say jumping, let's talk about jumping, but not in details. If you apply it to one industry, let's say agriculture, actually, maybe this is much wider. So, and maybe you figure out other industry which has even bigger problems. Well, probably difficult to find bigger problems in agriculture nowadays. Well, probably you can, but it's all subjective. But I find this, like, also what I really like the comparison is between also different like segments, business models. So like B2C, business to consumer, versus business to business. So like more industrial, business-oriented enterprise robotics products. Because I had chance to work for both, and like really either big brands or very like fast evolving startup scale-ups. And this is so different as well. And you have, although you might have very similar technologies developed for household robots, for example, to commercial robots, actually the context and the business model that you develop and what you care about in the product, what you optimize it for, is so different that actually this is two different words. Especially if you talk about like delivering products, so not just proof of concept, but actually having product that can scale, hardware products, like complex hardware product. Like, not saying that mobile phone is not complex, but I would argue that like robot vacuum cleaner is way more complex than a proper one than the mobile phone. So from like if you took some straightforward metrics of systems engineering, which I mentioned that I'm also systems engineer, which at some point I hope to point to. So yeah, so this is like, I find it in agriculture. I actually haven't, just to touch on this, I haven't been too much involved in before. I was actually tracking it and how robotics is evolving there, but there was not too much progress. And then I met the founder, CEO of HayBeeSee, and then I was like amazed, not just by how much like opportunities in product or company, but like actually how much is to optimize there. Like actually, you know, this is one of the industries like construction that, well, I mean, and this is true. Like construction is important because you build homes for people, but you know, there's many ways of doing this. But actually, growing food, this is like a even more major concern. Because I mean, you can live in caves, but you cannot really eat stones. I guess I'm not sure it's a good comparison.
Well, let's jump into HayBeeSee a little bit, and for those listening, the HayBeeSee, the link to the company is on the show notes, so you can get there. And it's hay as in the hay that horses eat, and then bee is in bees flying around, and then see is in seeing things with your eyes. HayBeeSee.com. And according to the website, it talks about it's a lightweight jumping all-season robot that basically jumps around, and I'm just going to interpret quickly, jumps around taking measurements, so then the farmer can basically make much more responsive actions based on different types of quality of what's on the ground. So if people are interested in more about the actual company, you can go look at HayBeeSee, and then what they're able to share is already there publicly, but it's still evolving. Question I have is, you said you're passionate about drones. Why is HayBeeSee not a drone solution? Because I would have imagined having something flying around taking pictures would have been vastly more efficient than something hopping around. What is the difference there, if you're able to talk about that?
Yeah, it's a very good question. So I'll try to make it a bit simpler based on also what I can talk publicly about. So this is also why I'm fascinated about projects which are very different, but different not for the sake of PR, but different because of very like fundamental reason. So when I think about, I will try to make a helicopter picture and then refer to HayBeeSee. So when I think about now projects, like after so many years of experience in robotics and complex systems, not just robotics, but any, let's say, more complicated product, what you really want to achieve, you want to understand what you want to build and how you want to build, right? So kind of requirements and so on. And it turns out that actually, you know, there's good methodologies developed in defense, in aerospace, in space industry, dealing with such a stuff. And why I'm mentioning this, because the story of HayBeeSee, like short story kind of fast forward, is in fact one of the early days, the solution that we looked into were based on drones. However, there was very good reason, and the reason is energy efficiency and the scalability of a product based on, let's say, current state of the art of electric batteries, that actually, plus few other actually metrics, which I probably don't want to or cannot talk today, which sum up to very unique advantage. It's not like unique select points, so just unique select points that it's okay, cool that we're hopping. Actually, jumping is, compared to multi-rotor drone, 20x more efficient. So when you said actually, oh, that the drone might be more efficient, it's actually 20x less efficient. And the reason for that is also that what is not obvious when you think about farming, and this is a bit of, let's say, the noise that you can see in the market. I'm not criticizing other companies or competitors, not at all. I'm just stating facts as they are, or let's say we think they are, and our partners think they are, is the data which you're collecting has to be actionable and impactful. Otherwise, like with any data-centered product, the product is marginal, impact is marginal. And it looks, I mean, it doesn't look like, it is an actually common truth across proper agronomy circles, that the data which matters is data which cannot be collected from drones in very simplified words. And of course, if someone is hearing this who is knowledgeable agronomy, you can still have like edge cases, but we're talking about also, let's say, widespread farming and not like specific orchards or let's say small use cases. So this is a bit probably long story.
I think that some of those principles apply is something I'm working on with a financial services company right now is a data analytics platform. And what I keep reminding them is the platform itself creates no value at all. It's if the data is properly shaped, if you will, granular enough, it's appropriate for someone to make a decision better than they would have otherwise. And so until a decision is made that creates value, the rest of this is waste. And it's in financial services where there's quite a heavy margin. Sometimes you get lost in the technique of data. And I imagine farming is not a high margin initiative, so probably any sliver of benefit they can get is worthwhile. So yeah, fascinating. Again, if people are interested, go to HayBeeSee.com, and it looks like a drone with legs. So go check that out. But let's loop back to your robotics and engineering, system engineering. You've mentioned that a couple times, and I can imagine myself how those are complementary. I wonder if they're even different. I don't know. Maybe robotics is a physical manifestation of system engineering. But what's your vision on how these things merge or how those two worlds collide?
Yes. So a bit probably of definitions as I see them, because of course this is all subjective always. So small disclaimer. So mobile robotics or robotics is a field of discipline I see it as industrial discipline, not just academic, of delivering a mobile robot, right, to specific applications. And mobile robots are complex systems. And that's where is the link with systems engineering. So systems engineering is a methodology, science, or whatever we call it. Maybe not science. Maybe some scientists will be a bit problematic about it. But this is a whole discipline of delivering complex systems. Probably this is not like the definition you would again look up for, but the whole idea is how to efficiently deliver complex systems. And so this is something coming from, I think this was from Bell Labs actually, where the first ideas developed and then very fastly spread to aerospace, to NASA, to all organizations where there's no other way. So it's not like nice to have there, otherwise you will not deliver, let's say, a new complex jet fighter, right? So I'm just talking, and still we are not delivering things on time and so on, but at least you're delivering it. And now, so this is a quite of, I think, opportunity which I had over my career, because I don't have like formal background in systems engineering. I have not been taught systems engineering at university. Well, I had some in UK at Cranfield University at Defense Campus, but other than that, at that time I haven't been taught how much value it gives. So the first time I heard about it properly was when I was at this drone company, Aerotronics in the Netherlands. So it was like rapidly growing drone startup back 2012. So pre-DJI Phantom, so really ancient drone days. And we're, by the way, developing a custom multi-rotor drone, so quite complex project. Those commercial B2B, so a bit more slack on the cost, but still challenging. And we worked with someone who came from aerospace background, not just single person, but a team. And that's where I was actually blown away by. Okay, so I spent a year in this company doing pretty much systems engineering role, some leadership of team, some bits and pieces, like pretty much universal growing first employee in the company, first engineer. And then someone's coming to me and saying, well, this is not reinventing the wheel. Actually, what we are doing, there are tools for that. Of course, not applicable directly to startup because it's too much overhead. But actually, there's some other people that thought your way, or not way, but trying to solve complex systems. And what is interesting about current industry, I don't think so many robotics companies, my robotics company, except the ones maybe in defense, but not even, I think most of them, from what I can say, but there are still small companies, they're applying or they see benefit or they know about systems engineering. Why is that is probably different conversation, but it's
Well,
like...
What I love about what you're saying is you're talking about systems engineering in a different meta context than I think we usually use the term. So in IT land, a systems engineer is a person who configures servers, systems, which are also complex systems in themselves, but we don't usually connect those two words and those two. And so what you're talking about is the system of a very complex thing, of many, many moving parts, a complex thing, maybe not complex adaptive system, but at least a complex system. And then probably the mindset and the techniques to comprehend that in order to deliver it over time across multiple teams. If there was one video or book or article that you would recommend people read to have a primer on systems engineering in this larger definition, what would you point people to? Do you have anything off the top of your head?
Very good question. I think this is a very good question, which I never asked myself, because I try to always probably reinvent the wheel against systems engineering, trying to explain on like maybe more proprietary examples, which I cannot talk publicly. Well, I think there's few organizations, including one called INCOSE, ENCOSE, which is the Council of Systems Engineering, and they have materials on the website. It might be overwhelming, I guess, because this is mostly for a bit bigger projects. I'm not really aware of any like kind of smaller scale applications of like publicly available systems engineering. But I think good example of this is also like books, which I cannot remember the titles from my mind, which talked about failures in complex systems. So, and this might be even, because this is a bit wider than like the software world, right? I'm not saying that software world is not complex and straightforward, but systems talk about not only like different disciplines, so like software, electronics, so this hardware product, but also about business. So this is absolutely meta, as you said, meta approach. And I think there's a lot of opportunities applying this in startups. It just, it's so difficult. Yeah.
Well, if we can, we will follow up and put in the notes the link to the INCOSA, and also we'll find at least one book about failures or lessons in maybe systems engineering or complex systems gone wrong, which are always interesting. So if we turn the page a little bit and went very, very broad, and you were talking to a large audience of business people who have actions that they need to be optimized in robotics, physical robotics, because robotization, like as in process automation, is another word that we're not talking about here. So, but we're talking about physical robotics. Where would they start? So, like if there was a corporate, say, executive of operations that was saying, if I had a drone or a hopping robot or a walking robot or some sort of mobile robot, how would they start that thinking process? Yeah,
so this touches on the innovation, I would say, wider topic, but I'll try to be as applied and as specific to robotics as possible. I think with like wider organizations, of course, it's very different decision making. But okay, let's say we have like executive who has all the power to make things happen. Like I assume this is the case, right?
Yeah, that happens all the time.
All the time.
Assume that's for this story. Assume that's true.
Yes. So, so things should, I think, come from. You should build capability, and what you are talking about is to figure out how to take advantage, or you want to improve some specific metrics of your business, or maybe find out which can be improved with some robotics technologies for whatever reason. I mean, of course, like maximizing profits should be the reason, and maybe sustainability, impact, or many other metrics. I think building in-house innovation team, robotics team is first thing. I would definitely not like go to consulting or consulting companies. I mean, you can talk to consultants, but you really want to have kind of not biased opinion. And yes, setup would, I guess, give it a bit of, I think, freedom as well. So and get of course executive there, or like, let's say senior manager, researcher, or senior leader who can who has the vision and who's seen enough, I would say, because nowadays the robotics technologies are quite distributed across sectors. There's a lot of great work also going on in academia, but obviously academic work and then deliver products, if you don't have in-house team yet or building it, it's not necessarily the best direction. I mean, you should definitely talk to top research groups, because they will give you like 10 years outlook and you can get inspiration. And I guess give them also some use cases, like actually each of the segments of the business. So if we have business which is maybe primarily logistics, or have logistics, big operations or logistics, and we want to optimize some parts of it. Warehouses, of course, are most straightforward, but this is becoming a bit more, I would say, I won't say major market, but there's a lot of in mobile robotics, in logistics going on. And there will be some very new things, and having people who can give you not develop technologies yet, but maybe they should in longer run, but they are able to be the visionaries, I would say, applied visionaries, but also trying to prototype some stuff, because like vision simulation is great, but
I wanted to bring that into the iterative innovation approach, prototyping. As I shared with you earlier before we started recording, that there's some Disney in my family, and I'm watching on Disney Plus right now the history of the Imagineering, which used to be WED Enterprises, Walter Elias Disney. Dad used to work there. And in the I guess this would be the 60s and 70s, when they were really pioneering the animatronics. The way they described it, at least in that documentary, was they just were tinkering. They wanted to create a bird that talked, that was synced with sound. And so they just started cobbling in their workshop. When you're approaching system engineering level projects, I'm just really curious, how do you balance that iterative versus master plan? How, what is because there's no way you can have a bunch of people in the room that come up with a blueprint of, the Death Star, and oh wait, no, they did that. No, but a fighter jet, and then have it work at once. What is the balance between prototyping and building to master plan?
Yes. Very good question. So I think, like, without going into too much details of because systems engineering has different frameworks, different processes, how you can apply this, and this is just guidelines. So it doesn't give you a step-by-step instruction saying you have to do like 100 pages documents and like link them with some master software together to make the jet fighter. It's more about like guideline of the process. And now this process, of course, can be tailored to any. And I think like the innovation phase is part of the like requirements analysis, I would say it. So when you say requirements analysis, you can think about just talking, or let's say talking to your customers. And maybe it's true for more straightforward products, which you more or less can see existing technology that you apply, but those are single technologies. So if you're talking about software as a service enterprise, where there's no, let's say, AI, no deep tech, well, most of these things, if you have few senior people, you can figure it out, right? Let's say if you know the vision of the customer, so you can iterate a lot of things, I would say, on paper and prototype quickly. And when it comes to robotics or complex systems, like jet fighter is a bit different, maybe more difficult than robotics, because well, you cannot fly jet fighter unless you build it, but you can fly in simulation though, and in like low fidelity, high fidelity. So defense has its different ways and more strict processes. The criticality of the projects are also higher. So in terms of like robotics, so maybe I'll give example of robotics and how this like Disney imaginary group might have worked if it were in system engineering. So they were given either complete freedom of doing whatever topic they want. So just choosing the topic is already a requirement specification or analysis, because you know roughly what you want to maybe build. And then you build something, and then I guess you can, in this case, say that, okay, how it works. You still need to know what's your metrics, what's your KPI, whatever you call it, how well it works. And this is maybe like even pre-project definition. So maybe it's not even requirements analysis, it's just like pre-innovation stuff or innovation phase, right? But of course, what is tricky with robotics is that these things takes time. So it's different time to prototype an app, like straightforward app, and it's different to prototype animatronic heads, which looks like not like a Lego build. Not saying that Lego builds are not awesome or great, because they are, but something which actually is useful and demonstrates and gives you some capabilities of these requirements analysis or thinkering, as you said. And like true innovation, like some companies they do have like in-house innovation teams which might have freedom or like think 5-10 years ahead, or many have actually. No, it's not that some like this 5-10 years ahead thinking, but they probably have very clear goals. That okay, we want to improve, let's say, some subsystem. I know we're thinking about sensors in Apple products. Then they definitely have like sensors research team. So I think this is kind of a mix of depending how you want to get it. But this iteration, as you go further, I think there are modifications of like traditional systems engineering, which try to make things a bit more agile, but still like agile is pretty much in opposition to systems engineering, not because of the let's say the principles, because I think both of the methodologies want to deliver the same high quality product which customer wants and is meeting requirements. It's just I think the complexity and time of prototyping is different for complex products, especially hardware complex robotics, than this agile approach, which potentially you can get to very unoptimized solution with agile approach, with a lot of iterative small steps without correction to the big picture. So there's a difference between
I would hope, and I guess you could differentiate agile done well and agile done not so well. That, particularly if you have cross team agile development, some sort of scaled approach, that you would have a design authority governance of some sort that would bring you towards the end goal. Because I think if you, I tend to agree with you, with a low maturity agile approach and you worked on subcomponents in isolation, the chance of success would be, well, low, shall we say, without some sort of rigor. I would imagine that your systems, complex systems approach would give a wonderful scaffolding or framework for which then within teams could work in an iterative or agile way. But that's I think it really depends on the context. Lovely insights. I'm about to wrap up. I'm curious. I have one more question, and then I'm curious if you have anything else that you would like to share. And I'm totally forgetting what my question was, because you cut me off on the agile thing. One thing that I was speaking about with my son recently was, because something we do occasionally, like once or twice a week, is go out walking in the streets in the forest and pick up trash. And we were sort of imagining, wait a second, why isn't there a little robot dog or something that's crawling around that has sensors to know what a leaf is or a toy, which basically don't pick up, versus a piece of trash, and you just pick it up and then deliver it somewhere. I think that would be an obvious use case. Do you have any idea why that hasn't happened yet? Like why do these solutions not exist yet to make our lives much better?
Yes, so very good question. Why we're not living in sci-fi as 10 years ago we thought or 20 years, right?
Yeah.
Pretty much. So I think this is about the level of technology maturity of some enabling technologies which robotics is relying on. So when I'm saying that is in order to, so what you want to do, you want to not have a dog, but like a doggish looking child or a device with a computational capabilities or cognitive capabilities of a child to be able to pick up trash. Because if it was like just animal, will be training, right? Animals to do the trash collection. We're not doing it for some reason. I'm not sure what is that, but
great point.
But anyway, we want like some serious, actually quite serious cognitive capabilities. And this is something which is not very straightforward, that these capabilities, it's not, first of all, there's some physical aspects. So you need to have like a power system that is powering you over, let's say, enough time so this device can go there and go back. Because if there's no charging station, so one infrastructure, it becomes not feasible. So, but we're getting there, let's say, or let's say we will get there over time. But the main thing actually is, or let's say one of the key factors which was blocking was there was not enough computational capabilities in terms of like processing, onboard processing, to run some sophisticated machine learning models, to do perception, to do some planning and so on. So those are all fragmented and you cannot really run them on the device. And now these things are progressing quite rapidly. You can see what type of progress in machine learning we see across. But this, I think it will still take some time until we have like a scalable mobile robots deployed. I mean, we're working on it in many different projects, including, with our startup, our company. But like true autonomy is, and you can see this what's going on with autonomous vehicles industry now, because this is, let's say, comparable task, let's say in terms of difficulty. Some people can argue, but this is autonomy, when you have to have fully autonomous thing which you can rely on. Criticality and safety is different aspect. But the problem is that with these technologies, it depends on the approach, how you train these systems, how you deploy them. And it's relatively straightforward to get proof of concept. And getting from proof of concept to like either safe or reliable system is way different story, because I would argue there's no real autonomous product there yet. Like you have some drones which are autonomous, but how you define level of autonomy? And this is a different discussion. Yeah. And there's some quite very interesting people in industry trying to explain why we don't have yet autonomy delivered. And I can give you the link to these people, and I think will be a great person to speak to on your another podcast as well. But I will leave you later for this discussion. So yeah,
lovely. And please share the link. And I remember the last question, which was my closing question, was you are moving through time in your career and working on different projects. So I'm just curious, what would be the dimensions of dream projects for you, and then how can people get in touch with you?
Can you repeat the second one?
Well, like how, because you're with HeyBeeSee right now, and then looking at your career history, you'll be moving to one or multiple. You seem to have a portfolio of projects going on. You've already mentioned that that some sort of novelty is there and things, but what types of problems would you love to solve for those people listening? And then if they have those problems, then how can they get in touch with you?
I see. In terms of HayBeeSee specifically, right?
No, about you.
Okay.
Yeah, like you as the robotics system engineer expert that is moving through your career, solving these incredible problems. What would you imagine some future problems be that you solve, and how would you engage with people?
Yes. So the problems I see. So I see this as a kind of top-down approach. So when you have some, well, first of all, if you have vision of actually deploying very serious mobile robotics. And by serious, I mean not in terms of budgets or importance in your company, but just like building capability. This is the first step. And like the technologies I'm excited about is actually, well, locomotion is difficult, I think, because like it's not necessarily about like specifically jumping or flying or walking. I think it all depends on what you want to do, and it might be actually a combination of a fleet or maybe methodologies, because you also have manipulation, which is more than locomotion. It is actually manipulating objects, and many other aspects. I think like probably the most exciting problems are not the ones that you hear like in newspapers and in media, and they are actually being solved in a quiet background for really important problems, because I don't think so autonomous vehicles are the biggest problem on the planet, which we spend the most cash or a lot of cash recently. So yes, I think this is what I'm excited about problems that are solved by technology top down. And the way how to engage with me, I'm on LinkedIn. I mean, I'm very much committed and fully engaged, more than 100% time with my current project. But if there's anything that maybe we can work together, LinkedIn is probably the best way to contact.
Lovely. Thanks so much. I know little about robotics. I knew very little, but thank you for joining and thank you for sharing. Is there anything last points you'd like to share before we wrap up, or has this been good enough for you?
It's been good enough. Maybe I'll make for people who are really interested in robotics, like either executive level or someone who wants to develop their career or they are in their career. I highly encourage to be critical about a constructive criticism about some approaches which are developed in not just in industry, but like this is complex systems. So I really encourage systems engineering approach applied. Yeah.
And we will put a link to the INCOSA, which is that society of systems engineers in there. So then people can get some tips and tricks that way. So Tomasz, thank you so much for joining. It has been a delight and it's been educational and inspiring. Thank you so much. And for people who are looking for more information, you can go to the show notes, which you can get a hold of by whatever platform you're listening. And in there's a link to Tomasz's LinkedIn profile, as well as to his current company, HayBeeSee. Tomasz, thank you so much.
Thanks very much, Chris.
Learn more at ebillion.com/podcast.